Okay, so let's talk some L'Hopital. I'm not sure how much of this you guys did. So, pretty confident in your guys' skills on figuring out page 46 of the L'Hopital notes. Some pretty simple L'Hopital problems on page 47. I'm sure at least one of these you had to use L'Hopital's rule twice or maybe even 3 times because you kept getting an indeterminate form when you plugged in for DSP. So you got to memorize these indeterminate forms here. You can only use L'Hopital if we have an indeterminate form. If we don't have an indeterminate form and we get undefined, it's actually a chapter 1 problem, a straight up limits problem. So let's look at L'Hopital. Remember, mentions if, where is it? If we have a fraction, a quotient, we can use L'Hopital. If we don't have a quotient, we can't use L'Hopital. So let's look at this page 48. I'm going to try and do all of these. Let's see if my brain is still with me. So this is not a quotient. I have to make it into a quotient, and there's 2 ways I can do that. I can do, well, we should first check if it's an indeterminate form, right? What happens to x squared as x goes to negative infinity? Well, x squared looks like that, right? Negative infinity, it goes to infinity. And then e to the x looks like that, right? Something like that. That's a bad graph, but it goes to 0 as x goes to negative infinity. Infinity times 0 is an indeterminate form on our list. So we can use L'Hopital's, but we have to make it into a fraction. So I can either do this, or I could move the other guy. How do we know which one to do? We don't. We can hope we get lucky, and if it doesn't work, hopefully we realize it's not going to work, and then try the other one. So if I'm remembering correctly, I actually want to do this one first, because I want to show you why it doesn't work. So all I've done is algebra. I don't have to recheck that it's an indeterminate form. It will still be an indeterminate form because I haven't done anything other than algebra. So if I use L'Hopital, I like to write a little h there just to indicate, and no, I will not mark you off if you don't write the h there. L'Hopital says not quotient rule, but just take the derivative of the top and the derivative of the bottom, right? And then try DSP again. So we have this e to the x graph again. E to the x goes to 0. And then, oh boy, what is this? Negative 2 over x to the third. What does that graph do? Well, it's going to be similar to a 1 over x graph, just steeper. And instead of going through 1, 1, it's going to go through 1. Oh, I didn't flip it, did I? Because of the negative 2, it would flip. It's not going to change the answer, but just to be sure. As x goes to negative infinity, the y is going to 0, so we still have an indeterminate form. So let's try L'Hopital again. E to the x, well, that's not helping me. Power rule here, 6x to the negative 4th. Let's check out, see what DSP is doing. 6 over x to the 4th is going to be like 1 over x squared. Similar to 1 over x squared, which does that. It's going to be steeper. As x goes to negative infinity, the y is going to 0. And e to the x hasn't changed, so I'm stuck in a constant loop here. E to the x is staying the same on top, so the top is staying 0. The bottom is alternating between even, odd, and even powers under or as the denominator of the fraction, so it's literally alternating back and forth between these 2 graphs. So I'm in a loop that's not helping me. So that is not the fraction that I wanted to use. So maybe you get lucky and you realize that this one is the one from the beginning, or maybe you have to go through a little bit of work first. So L'Hopital over here, derivative, right? 2x is just a line going through the origin as x goes to negative infinity. So if I'm trying DSP, that would be negative infinity. Oh boy, negative e to the negative x. So do I have room up there? That would flip this graph along both the x and the y. So flipping along the y, and then flipping along the x. I hope you can see that. Yeah, you can see that. As x goes to negative infinity, this is going to negative infinity. So I still have an indeterminate form. This is getting really frustrating. There is a light at the end of the tunnel, I promise. So I can use L'Hopital again. I don't have space to do my little equal h here, but maybe you can do that on your paper. Derivative of the top, derivative of the bottom using chain rule, and using DSP. There's nothing to plug in here. So the numerator is going to stay 2, and I know automatically it is not going to be L'Hopital because there's no indeterminate form that has a 2 in the numerator. Denominator, as x goes to negative infinity for e to the x. Remember, this green guy was e to the x. Whoops, that's the other page. As x goes to negative infinity, this is going to 0. And you're like, well, that's still undefined. But remember, with limits, we're not talking about equal 0. We're talking about getting very, very close to 0. So if this is 0.00000000001, let me write it out because it's been a while since we've seen this. That would be as a fraction, something like that. And instead of dividing fractions, we multiply by the reciprocal. So that is a very large number, infinity. Okay, I don't remember the rest of them being this long, but I guess we'll see how it goes. All right, so B. Actually, let me jump to example 2A first, so we can get at least one of those done. Okay, so this would be our 0 raised to the 0 indeterminate form from the list at the beginning. And it's not a fraction, and there's no way to make it a fraction. But wait, remember before I left, we talked about a way to make something like this into a fraction. So let's take our function, and let's take the natural log of both sides. And that allows us to move that exponent in front. And now I can make it into a fraction. So I'm going to actually take the limit of this natural log thing, and it's going to lead me to the limit of the thing without the natural log. So we have, again, two choices, just like we did in the previous example. We could either move the natural log to the bottom, or we could move the x to the bottom. I'm going to hope that the x to the bottom is the correct one, because otherwise it's going to be kind of yucky. And then again, we have only done algebra, so we don't need to recheck that it's an indeterminate form. It is. So I'm going to use L'Hopital. And then simplify this before you start like trying to decide if you can use DSP or if you need L'Hopital again. This is 1 over x over negative 1 over x squared. So I'm dividing fractions. I need to multiply by the reciprocal. And lo and behold, this is like the easiest thing we've done all day, because that simplifies to negative x, and then now I can just plug in the 0 and get a 0. Oh, but that's not the answer. We thought we were in the clear. This is the limit for this natural log thing. So this is the limit for the natural log of the function, not the function itself. Well, how do I go back from, if I have an equation involving a natural log and I want to get rid of it, I want to solve for y. How do I undo that? Well, I would do e on both sides, and that would cancel, right? So my answer is actually e raised to the 0 power. So for the original, my answer is 1. Anything to the 0 power is 1. So let me do one more of those because those are kind of freaky. Let's do B on example 2 on page 48. Okay, so as x goes to infinity, we've got the e to the x graph. Hopefully we all know what that looks like. If we don't, we're not studying enough. So as x goes to infinity, shooting that way, the graph is shooting up, going to infinity. So this infinity plus infinity raised to the, what's 1 over infinity? Hopefully you remember that from chapter 1. 1 over infinity, 1 over a very large is very small. So this is infinity to the 0, and that is an indeterminate form. So I'm going to use L'Hopital, but again, I can't make this into a fraction. I got to deal with this exponent that has a variable. So this goes back to logarithmic differentiation. When we have a to the x, that's an exponential, and we have a formula for that. When we have x to a number, that's a power rule, and we have a formula for that. But when we have a variable to a variable, we have to do a log. So that's what we're doing here. We're saying our function is this ugly thing, and we're going to take the natural log of both sides so we can move that exponent in front. And we're going to take the limit of this thing, and that will help us figure out the limit over here. So if I take the limit of this, what am I going to? Infinity. So this is actually already a fraction, right? Took no thought. So instead of writing 1 over x, I'm going to put the x in the denominator. I have only done algebra. I don't need to recheck indeterminate, so I'm going to do L'Hopital. So I need chain rule for that numerator. Derivative of natural log, leave the inside alone, multiply by the derivative of the inside. And then denominator is just 1. So I'm going to check DSP again. E to the x, again, as x goes to infinity, that goes to infinity, infinity plus 1. Still infinity. And then same thing here, infinity plus infinity is still infinity. So L'Hopital again. Derivative of e to the x plus 1 is 0. This is e to the x plus 1. Right. DSP again. As x goes to infinity, the y goes to infinity. So again, I have infinity over infinity, but hopefully you're seeing that now. One more L'Hopital will be it, because derivative of the top, derivative of the bottom. Anything divided by itself is 1, and the limit of a constant is the constant itself. Remember, this is not the answer we want. This is the answer for this limit involving the log. The problem did not involve a log, so I need to undo it. The way I undo a log is by doing a base e, so the answer is e to the first, or e. Okay.